Nylon, a plastics presentation by Mariella Manipol, video number 4, for Materials for Industry, Professor Pastor at Tidewater Community College. What is nylon? Nylon is a type of synthetic polymer. Specifically, it belongs to the polyamide family of plastics. It was the first commercially successful synthetic thermoplastic polymer invented by Wallace Carothers and his team at DuPont in 1935. It's formed by linking repeating units containing amide groups, CO and H. There are around 50 different types of nylon, and different types vary greatly in structure. So here we have the structures of nylon 6,6 and nylon 6. Now, if we have any other type of nylon, like nylon 610 or nylon 12, those would look different. Here are more pictures of nylon. So some common types of nylon would be nylon 6,6. It's made from adipic acid and hexamethylamine. It's known for its high strength and thermal resistance. Another common type of nylon is nylon 6, made from caprolactam, which is slightly lower in the melting point and strength, but it's easier to process. Some other variants include nylon 11, nylon 12, and as I said, nylon 610, etc. Some properties of nylon: it's strong and lightweight, it has a high tensile strength, it has good abrasion and impact resistance, it's self-lubricating, it has excellent wear resistance, good flexibility and fatigue resistance. It absorbs moisture, which may affect mechanical properties. It's thermally resistant, but it melts around 220 to 265 degrees Celsius, depending on the type of nylon. In this picture, I have an AI-generated photo of nylon in a compression resistance test. These are one of the tests that manufacturers use to test nylon and its properties. Some uses of nylon would include textiles, such as clothing, ropes, fishing lines, carpets, and parachute fabric. Automotive parts like gears, bearings, under the hood components. For industrial components, it is used for electrical connectors, fuel lines, and tubing. In consumer goods, it is used as toothbrush bristles, zippers, sportswear, and luggage. And finally, but not least, engineering plastics for machine parts, casings, and fasteners. So here's a visual example of what nylon is and can be used for or in. Let's get into the manufacturing process. First, we'll start off with polymerization. Monomers undergo condensation polymerization, releasing water as a byproduct. When combining a diamine and dicarboxylic acid, it will react to form amide bonds. A common example of this would be combining hexamethylene diamine and adipic acid under heat and pressure, which forms nylon 6,6. So here we have polymerization of nylon 610. So here we can see the two different substances mix together and react to form our nylon. And here we see the structures, the chemical structures linking and forming. Next, we have extrusion. The polymer melt is pushed through a die to form long fibers or pellets. Nylon resin is heated and fed into an extruder. It's melted and pushed through a shaped die to make the desired shape, formed into a continuous profile. See here you can see the machine extruding the nylon into a continuous long shape. This is the production line. Next we have texturing and pelleting. Depending on its use, it's either spun into fibers or cut into pellets for molding. Texturing gives the surface a specific texture for application, like carpets. With pelleting, it is melting and extruding nylon resin into small uniform pellets. Pellets are a common form for industrial use, allowing for easier processing and handling in applications. For example, creating a 3D printing filament or manufacturing machine parts. Here we have some pellets. So it would usually be formed in this production line and cut continuously to form these little small bead pellets. Lastly, we have fabrication. So it's processed into fibers for textiles or molded into solid parts via injection or extrusion molding. Injection molding for mass production and 3D printing. We have SOS and FDM for complex parts. It includes traditional methods like machining, die cutting, and laser cutting. It is crucial to dry the material for quality as nylon tends to absorb moisture. Here we have carbon fiber, nylon, PAO printed. Lastly, we have our factors on the environment. So nylon is not really the best plastic to make. It has a lot of, bad outcomes. So here are the top three. It has a terrible release of greenhouse gases, such as nitrous oxide, N2O. Nitrous oxide is a potent greenhouse gas. It is about 300 times stronger than CO2, carbon dioxide. It's released during the production of adipic acid, which is a key ingredient for nylon 66. But nylon 66 is also one of the most common types of nylon made. So even small leaks have a large climate impact. Number two, nylon is made from petroleum-derived chemicals such as hexamethylene diamine, adipic acid, caprolactam for nylon 6. Nylon production depends on non-renewable fossil fuels, increasing carbon emissions, resource depletion, and environmental damage from drilling and extraction. Number three, it requires high heat, especially in polymerization. High electricity consumption is used from this high heat. There's increased carbon dioxide emissions from power generation and large energy footprint compared to many other plastics is made. So thank you for coming to my presentation. Here are my many citations. Hope to see you in the next one. Bye.